पैसे दोगे तो आपको ही जहाँ आदमी ना महंगाई से साला मरा जा रहा है, तो आपको जाते जाते कुछ भी नहीं समझे। अरे वही 50 रुपए किलो है। क्या समझे आया अंदर खाओ कुछ जाओ एक दिन की सब्जी लाओगे तो यहाँ दो ठिकाने यहाँ रहेगा। हमारे परिवार में 1 किलो करोड़ी में कुछ होता नहीं। दोनों परेशान सभी का भाव पता है नहीं है। आपको साथ आपको लगता है अपने काम बस ये ऐसे रखते हैं।
भाई क्या बच्ची रहती हो।
Good afternoon, sir.
Good afternoon. We are into our meteorology session. This is our topic, tropical revolving storms, TRS, also known by different names in different regions. They are revolving storms, but they can be known by other names also, depending on the region in which they are blowing. The typical thing about them is that the pressure gradient around the isobars is very steep and they are almost circular. The pressure gradient isobars are almost circular. That is the typical thing about the TRS. They are smaller in size than latitude depression, but of far greater intensity. Isobars are two circles. Two circles means I would amend it to nearly circular. And pressure gradient very steep. So when pressure gradient is steep, but very steep, then you have very strong winds blowing. So depending on the strength of the wind associated with the storm, they can be categorized as follows. A tropical depression will have a wind force of 447 or less. Moderate tropical storm, before force 8 and 9. Severe tropical storm, STS, before force 10 and 11. And hurricane is something to do with a before force 12 or more. Because the wind is very strong and they blow with intensity, they will raise what is called mountainous seas. Destruction is very extremely violent and very catastrophic phenomenal destruction can cause. We are concerned with ships. The names given, which is also part of mentioned in the syllabus, is like this. North Atlantic western side, they are called hurricanes. Season, identified season is June to November. On the eastern side of the Atlantic, they do not occur. South Atlantic, they do not occur. North Pacific, western side, they are called typhoons. Local names, typhoon, western side, the North Pacific. Season is almost all the year round. Worst period, of course, recognized as June to November. North Pacific, eastern side, they are called hurricanes. June to November is the season. In the South Pacific, western side, they are called hurricanes also. Season now is different. Eastern side is June to November. Western side is December to April. In the South Indian Ocean, which impacts us living in India, they are called cyclones. On the west side and on the east side, they are called Willy Willy. Season is almost similar, December to April, for both cyclones or Willy Willy. Season identified is December to April. Although the season is recognized as like this, but as we had seen in the global warming also, times are changing. Even the seasons are changing. For example, right now we do have one cyclone blowing along the west coast of India. Which is not December to April, somewhere in October. Of course, we will be concerned since cyclone is also a kind of DRS. This is also a concern in the Arabian Sea and Bay of Bengal. TRS generally they are like this. They will blow with intense fury, etc. Isobars are nearly circular, but TRS will be different from different. One TRS will be different from the other one in size, intensity, and behavior. The only thing which is generic is that they blow in the fashion to raise mountainous swell and the isobars are circular. That is the only thing which is common to it. Otherwise, each TRS will be different regards to the size, intensity, and behavior. Tracks and rate of travel can also vary. They usually form the TRS near the Intertropical Convergence Zone or ITCZ in short, which is an area of instability. That is the normal area from where they start, the origin. So this is a storm system, low pressure center, of course, winds blowing with gale forces spirally inwards, anti-clockwise in northern hemisphere and clockwise in the southern hemisphere. The winds will blow spirally inwards, anti-clockwise in northern hemisphere and clockwise in southern hemisphere. Deflection, of course, is due to Coriolis force. So these are the other names which we have just now seen. Cyclone in Bay of Bengal, Arabian Sea, hurricane in the western side of North Atlantic and South Pacific, Cordonlanzo on the eastern side of North Pacific. Nickname, typhoon on the western side, Willy Willy on the eastern side of South Indian Ocean, which is something like Australia, New Zealand, nicknamed as Willy Willy. This is a bird's eye view, if you can say, or a satellite photograph of a full-blown TRS, tropical revolving storm, hurricane with an eye in the center, and all this is the periphery, a satellite image. Classifications. Zero to 6 before scale called depression. Just called depression. This is a start. This is how it starts. When the wind forces increase to before scale 7, wind is blowing to 28 to 29, 30 to 33 knots, then it is called a deep depression. In Australia, it is called a tropical low. Different names, but meaning the same thing. Southwest Pacific, it can be called as a tropical depression also. With the wind force increasing to 8-9 and in speed 34-47 knots, it is called a cyclonic storm in Indian Ocean. Cyclonic storm. While in Southwest Indian Ocean, it may be called as moderate tropical storm. Just a way of classification, that's all. When the wind force has increased to 10, before scale 10, then it can be called a severe cyclonic storm or a severe tropical storm, STS. And of course, this red color zone with before force 12 or more is indicating a very severe cyclonic storm. While if this is happening somewhere near Japan, Northwest Pacific, JMA is the short form for Japanese Meteorological Authority, then it is termed as typhoon, or even going further, super typhoon. How is it caused? Just to some points for the cause of it. Warm, moist air. Warm air over 27 degrees Celsius and moist rises from the surface of the sea. When it rises, it meets cooler air, condenses to make clouds and rain. It is rising up, it meets cooler air on top, and then it condenses to make clouds and rains. This condensation releases huge amount of energy, which is called latent heat, producing strong winds. This condensation releases latent heat, which is huge amount of energy, and it produces strong winds. The winds are of course driven by the spin of the earth. Coriolis force deflects it. Consequently, as we said, it moves like this, clockwise in southern hemisphere and anti-clockwise in northern hemisphere. But in both the cases, whether they are clockwise or anti-clockwise, they blow spirally inwards. Only the direction is anti-clockwise in northern and clockwise in southern, but they do move spirally inwards. Now, what is fueling them to keep on moving and developing is the dampness, which is moisture, and the energy, which is latent, which is the hidden energy. Wind speeds could be as high as 200 kilometers per hour. Just for reference only, 200 kilometers per hour has also been clocked in these storm areas. So the ideal condition for a TRS will be mid-ocean, latitude between 5 degree to 20 degree. We are looking at the development, the origin. Of course, it will move, but this is the place where it will start. The fun will begin here. Latitudes 5 degree to 20 degree, mid-ocean, and you must have relatively high seawater temperature, over 27 degrees Celsius something, and moisture laden air. This is the ideal condition for the formation. So they originate in latitudes between 5 and 20 degree, travel between west and west northwest in the northern hemisphere and west to west southwest in southern hemisphere. Speed is about 12 knots. Somewhere during their track, they curve away from the equator to north and then recurve to northeast in northern hemisphere. So they travel north, curve to north and then northeast in northern hemisphere, south and southeast in southern hemisphere. This is showing you a few points like track, path, vertex. Track, the route over which TRS is already passed, that is called the track. The route over which the TRS is already passed. Path is the predicted route over which the TRS is likely to pass. So track is the history where the TRS is already passed. Path, on the other hand, is the possibility of the TRS passing. The predicted path or the predicted track, let's say, over which the TRS is going to pass. The westernmost point of the TRS is called vertex, from where recurving takes place. This one. So just to be sure, you must remember track is the past path over which the TRS has already passed, and path is the predicted track over which it is likely to pass. This is the one predicted track, but this is showing where the TRS is already done. And vertex is the westernmost longitude where the TRS comes and recurves, from where it starts recurving. Southern hemisphere, the same definitions will apply, path and track, but the path will be like this. The only difference is that after reaching the vertex in northern hemisphere, the TRS is curving towards northeast. While in southern hemisphere, it is going to curve towards southeast. But the path and track definition will stand still, and vertex will be the westernmost longitude in both the cases, whether northern or southern hemispheres. The fact is that once the storm has recurved after reaching the westernmost longitude, recurving, then the speed of the storm increases, speed of travel. After it has recurved at the vertex, then the speed of the travel increases. But having said that, it is to be recognized that sometimes TRS may not recurve at all. It may just continue on the original path, cross the coast and then dissipate because it is going to lose momentum due to friction and hitting the landmass. It is also possible some of them do not recurve at all but continue on the original path. They cross the coast and then dissipate because they will lose their energy due to friction. And of course, this is blowing over the coast or land, there is lack of moisture, which is a necessary ingredient to make it move. Again, since it is not necessary, there is no law of physics, some storms may remain stationary or make small loops over a almost stationary place, location, then make small loops. And this can continue for maybe even 4 days, 5 days. Now you can divide the semicircle into two parts. One is called the right hand semicircle, which is simply half of the storm area which lies to the right of the observer who faces along the route. And over here, the wind will veer steadily. That half of the storm which lies to the right of the observer who is facing along the route of the storm. You can divide it into right hand semicircle and the left hand semicircle. Left-hand semicircle is that half of the storm which lies to the left of the observer who faces along the route of the storm. For here, for a stationary observer, the wind will back. So in the right-hand semicircle, the wind will veer, and in the left-hand semicircle, the wind will back. This is true for both northern and some southern hemisphere, irrespective of the hemisphere. Face the root of the storm. On your right, you have what is called RHSC, and on your left, you have what is called LHSC. Quite simple. Now, in the northern hemisphere, conditions on the RHSC right-hand semicircle are more severe than those on the left hand. So, for this reason, in northern hemisphere, right-hand semicircle is called dangerous, and left-hand semicircle is called dangerous in the navigable semicircle in the northern hemisphere, and ulta opposite in the southern hemisphere. In fact, on the other side, left-hand semicircle in northern hemisphere will be called navigable semicircle, while on the right-hand semicircle in northern hemisphere it will be called the dangerous semicircle. So you will have two semicircles, right-hand semicircle and left-hand semicircle. In northern hemisphere, RHSC is called dangerous and LHSC is called navigable. And this is opposite, completely opposite when you go to southern hemisphere. In which case in southern hemisphere, RHSC will be called navigable while LHSC will be called dangerous. So these two semicircles become important for avoidance, which is going to come later. To avoid the TRS, these semicircles are going to play a part. Now this is only relative comparison, mind you. Left to right hemispheres or semicircle, they are only relatively speaking. As a matter of fact, generalizing all area of TRS are dangerous. Because you have divided the circle itself in quadrant, then this becomes dangerous quadrant. As you can see, northern hemisphere, the right hand semicircle. So dangerous quadrant is the advanced quadrant, the one which is ahead in the right hand semicircle, while navigable one is the down part, the navigable semicircle. Dangerous semicircle is the this part, and is inside here also. Dangerous quadrant is the advanced quadrant in northern hemisphere. Completely opposite in southern hemisphere. Opposite in the sense it takes a different perception in the southern hemisphere. As you can see, it was shaded black in the northern hemisphere, the bottom part. Now it is shaded black on the top part. Dangerous quadrant is the one which is below in southern hemisphere, while dangerous quadrant in northern hemisphere was the one in the top part. These are some areas affected just by diagram only. They are showing the paths of various TRS. Cyclones, Indian Ocean, hurricane, Atlantic Ocean, and typhoon in North Pacific. These are only the probable paths for different hurricanes and cyclones in different areas of the world, ocean. Three distinct parts will be called the structure of the TRS. First one is the eye or vortex. Eye or vortex. This is a calm central area of lowest pressure. Diameter is between 4 miles to 30 miles, average being around 10 miles. Rough circular area of comparatively light winds. Fair weather, eye, the eye of the storm. As far as common language is concerned, when you say eye of the storm, it is very dangerous. But as far as meteorology is concerned and TRS, the eye of the storm is actually a very calm area, calm central area. It doesn't mean that you are out of woods. It doesn't mean that you are safe, but the area is which is called eye, it has got very calm scenario. Weather in the eye is normally calm, but sea can be extremely violent because of swell. Precipitation is almost missing. So it gives a very false impression that you are safe. So much so that if you see a photograph, then you can easily identify the eye of the storm like this. Very calm area. No swell, nothing. Swell is there, but no. This one. It is called the eye of the storm, which is a low pressure area, of course, the lowest pressure area, but little or no precipitation. Even sometimes from the eye of the storm, if somebody is unfortunate to be caught here, he can see blue sky. The second area is called the eye wall. This is after the eye, inner ring. But here you have hurricane force winds. The width about is something like 4 miles to 30 miles. Eye wall, in the eye wall, the winds will blow in perfectly circular path. Speed as high as 130 knots. Occasional gusts 150 knots. The most, you can say, dangerous area or impactful area, eye wall. Pressure gradient is very steep. Barograph just registers a vertical trend downward. Just goes down simply. The barograph, the most handy equipment to have on board as a mariner, the barograph. This will register a near vertical trend downwards. When you are approaching, the path is like this. Before you reach the eye, you are transiting the eye wall. Before you reach eye, you will have a vertical trend of the barograph. After you have crossed it, after you have crossed the eye, it will show a vertical upward steep. Thunderstorms, dense rain, strongest winds is a characteristic of eye wall. One minute. Show you that paragraph thing. This one. This is a trace for a typical TRS. This is the outer storm area. This is the eye wall. Eye is in the center. Now, as you see, barograph is dipping downwards. Nearly vertical trend. As soon as it reaches the eye, the lowest pressure is registered and then it starts to climb. Both this one and this one are called the outer storm areas. But inside the eye wall, before the eye, you have a vertical trend downwards. After the passing the eye, you have a vertical ascent of the barograph. On the y-axis, you have what is called the pressure. On the x-axis, you have time, maybe GMT. As you can see, pressure is falling. As you are approaching the eye, this is the barograph trace. It is showing pressure falling because on y-axis, you got the pressure. As soon as you cross the eye wall towards the eye, you have the lowest dip. This is the lowest pressure, and after you have crossed the eye, the pressure will start ascending again. Plotted against GMT or maybe LMT, but GMT is more likely just to be on the uniform side. So the eye wall becomes a ring of hurricane force winds. Width is about 430 miles. Winds in the eye wall blow in a perfectly circular path with a speed as high as 130 knots and gust up to 150 knots. Pressure gradient in the eye wall is very steep. Barograph therefore registers a vertical trend because of the pressure gradient. 1 minute to come back to our discussion, just to be very sure. Vertex, VERTX, is the term used for the westernmost point on the track. And vortex, VORTX, is the one which is used to signify the center of the storm. So we have 2 points, vertex and vortex. Vertex is the westernmost point and vortex is the center of the storm. Okay, to continue, we have followed the point about vortex and vertex. Then eye wall we have understood is the area just outside the eye. Here it is the strongest winds you will experience, strongest. Pressure gradient very steep and winds isobars circular. Not nearly circular, just a circular. Dense rain, heavy dense rain, strongest winds and blowing in circular path. Now any change in the structure of the eye for a formed TRS, for the formed TRS is blowing already, any change for a region in the structure of the eye or eye wall can cause changes in the wind speed. Wind speed is the indicator of storm intensity, so maybe if you have a lowered wind speed due to a change in the structure of the eye or eye wall, then you will have the reduction in the intensity of the storm. Beyond the eye wall, you have what is called the outer storm area. This is the area. No, you're looking at this one. Eye wall, outer storm area. This is the area having a diameter of 50 to 800 miles diameter. Average being about 500 miles. Very large area, outer storm area. This one. Winds are strong, but pressure gradient is much lesser than the eye wall. Cirrus clouds are normally sighted in this area, having ligaments aligned, pointing towards the storm center. The clouds here, cirrus clouds in form of ligaments with aligned condition, they normally point towards the storm center. In previous days, when the technology was not so advanced, this was the indication of where the eye of the storm is. Cirrus clouds aligned like filaments pointing towards the storm center. Visibility here is good, but of course, could be an issue regarding shower. Shower can reduce it, but otherwise, normally the visibility is excellent in the outer storm area. In the outer storm area, you will have what is called nimbostratus clouds. Nimbostratus, rain bearing, continuous rain, outer storm area. In the eye wall, you will have what is called cumulonimbus clouds with continuous precipitation, heavy rain. Altostratus and cirrus in the outer storm area. But just remember this one, nimbostratus for continuous rain in the outer storm area and cumulonimbus for heavy rain in the eye wall. And as discussed earlier also, eye is an area where there is no rain. In fact, the wind also is very less. It does not mean that everything is good, because this is just temporary phase. As soon as the storm has passed over you, the eye has traveled, then it will hit you from the other side. This eye wall will now come. It is only a temporary kind of a false relief that everything is good. Just because the rain has abated, you cannot see any clouds in the eye, wind has also decreased relatively, a false impression that you are in safe area. But when the storm is passed, it hits you from the other side, completely opposite side. So these are the stages: premature stage, mature stage, and then the decay stage. These are the stages of the TRS. Is share screen visible? I forgot. Yeah, it should be visible. So if you are answering or you are looking at a reason or cause of the TRS, then please remember these are the causes. Warm, moist air, 27 degrees Celsius, the seawater temperature rising from the surface of the sea. As it rises, it meets cooler air, condenses, and makes clouds and rain. This condensation is accompanied by release of huge amount of latent energy, which produces strong winds. Winds are driven by the spin of the earth. Coriolis force deflects it. Earth rotates. Wind sucked in violently towards the vortex. Now this is the formation of the TRS. So how do they actually travel? How do they move? They move because they gain energy from latent heat, which is generated by formation of clouds. Latent heat. This is the thrust is being provided for them to move. Energy is gained from latent heat and is driven by thunderstorm activity. Moist air is required to build this up. It is, sometimes it is compared as a vertical heat engine, which is also powered by Earth's gravity and rotation. Another factors which add to their movement is the Earth's gravity and rotation. This is formation. Curved cumulus clouds, they align themselves towards an active area of thunderstorm, which is the location of the center. Now, if at this stage of the formation, if the thunderstorm, if the TRS is located inland, at land, which is unlikely, but suppose it is like this is not going to do much damage, but only form heavy rain and floods in some area, which is also something which you see normally in Philippines, etc. Formation of the storm on land. It is going to result not in very big winds, etc., but torrential rain and maybe causing flooding. So that is the formation. Then the premature stage. Gale force winds are developing, strengthening the pressure gradient. This is a premature stage. Circulation center is now well defined. Eye has begun to form. Satellite and radar observations of the system will show as a distinct spiral bounding pattern. Premature stage of a cyclone can cause devastating winds, of course, and storm surges. Can cause harm to the coastline, and of course, shipping is always under threat. And then you pass on to mature stage where it is all done. Cyclone may continue to intensify, but this is more likely unfavorable. In this stage, cyclone is most dangerous if approximately half of the cyclone can come up to this stage. Most of them will dissipate, but if some cyclone reaches this stage, then it becomes dangerous. When it starts to filling up, the pressure gradient starts to decrease, the storm is filling up, and therefore it can weaken. Surface wind can weaken. Heavy or medium rain can be available or could be possible, but mostly the center is filling up. Right? We'll continue Take a small Kit Kat. We continue. Meet again. We meet again at 15:45. Okay.
Thank you, sir.
So that is how it goes. Right? Wind blowing from high level to low level, high area to low area. That is causing a pressure gradient. Coriolis force is deflecting it, and resultant path is like this. Signs of approaching TRS. Some points for that. Signs and symptoms that TRS cyclone is in the vicinity. These are the signs. Heavy and long swell originating from the cyclone center traveling radially outwards. Swell can be experienced many miles away. It is a usually first indication that a storm center is somewhere near. Or, in other words, an approaching TRS. Heavy, long swell. Pressure is going to start dropping and pressure will be lower than normal. Now, when pressure falls below 5 millibars from normal, then it is a clear indication that there is a TRS in the vicinity. We are looking at the pressure corrected for diagonal range, of course. After which, if it falls below 5 millibars, then normal pressure, it is a clear indication that there is a TRS in the vicinity. With advanced technology, many gadgets available, but still, this point still holds good. Cirrus clouds in filaments aligned towards the direction of the storm center. Because of reflection of the sunlight at sunset, cloud color will be dark red copper in color. Heavy rain, threatening appearance, clouds dense, these are all signs that there is a TRS in the vicinity, accompanied by frequent lightning. And of course, weather reports, which are based on satellite pictures, observations from other vessels, which can contain storm warnings. Which also contains weather reports or TTT warnings from other vessels when they have encountered area of low pressure. Sea waves becoming more and more heavy and dangerous, shift of wind direction, unexplained shift of wind direction because of cyclonic spin, occurrence of squalls, all these are signs when TRS is in the vicinity. Storm surges are also common. Tidal waves or storm surges. Very violent winds of the eye wall can stir up these. Typical tracks, tropical revolving storms, something like this, originating somewhere in these areas and then moving and curving. Some more of them. Very common here, called hurricanes, dangerous, and also in the Gulf of Mexico. So here they are called Willy Willy, and of course in the ocean they will be called cyclones. Interestingly, the one which is blowing now, I just now explored it. It is called Gulab. Extremely heavy rains in Marathwada, Maharashtra, Mumbai, other parts of coastal Konkan area. This is blowing right now, which is called Gulab. The after effects is going to be experienced in Gujarat also. The remnants of Cyclone Gulab are likely to enter the Arabian Sea on September 30th, intensify into a cyclonic storm, and then move towards our friends, so-called friends, Pakistan. IMD has issued a warning. Of course, they always do it to stay away from sea to fishermen. The storm TRS cyclone is named Gulab, which is blowing right now. In last 24 hours, because of this cyclone, in Kalyan and Dombivli area, rainfall up to 121 mm has been recorded. 121 mm. Right? This is the latest. Gulab. Of course, you can relax. You are far away from it, but after effects can be felt anyway. What are some features of the storms? Pressure, wind force, direction. When you talk of the pressure gradient, it is very steep within 100 miles from the center. Something like 10 HPA in 30 miles. The gradient 10 hectopascal in 30 miles, 50 miles, sorry. Also increasing. as you approach the center. So gradient is very steep. Wind force also increases with the coming close to the center, but at the center, no wind. The worst area is the outer wall area. The strongest winds will occur in the right hand semicircle in northern hemisphere and left hand in southern hemisphere. Now, rain or heavy rain, feature of tropical storm, usually starts as a light rain at a distance of about 100 to 150 miles from the center. As you approach the center, torrential rain increases. Hurricane force winds, extremely violent squalls, etc. start increasing. This can be accompanied by thunder and lightning also, which is a clear indication that you are near the storm center. But very clearly, at the center, you can often see blue sky. Size of the tropical storm diameter vary from 50 to 1000 miles, but not more than 100 miles area. Storm generally increases as the area progresses. Seasons are there, which we saw. There are seasons. In the West Indies and North Atlantic, the hurricanes develop in doldrums area, ITCZ, which is from June to November. This we have seen the different names, local names. We saw them, so we will skip this one. Arabian Sea, it will be called cyclone. As we said, Gulab is being havoc now, right now. That we are familiar with this. Different names in different areas. Now, there are few things we can talk about before we start thinking of, you know, one thing is that how will you actually define it? You can define it as a roughly circular atmospheric vortex originating in subtropics and tropics. Wind is converging in spiral tracks anticlockwise NH and clockwise SH. Also, tropical depression like this we have seen different grades of the wind force associated with wind force before force 7, 8, 9, etc. TRS originates between 5 degree and 20 degree, travels west and west northwest in northern hemisphere, west and west southwest in southern hemisphere. But the point is, why do they recur? Why do they recur? The point of recurvature is of course the westernmost longitude called the vortex. But why do they recur? So now it is recurving. It can travel straight, but no, it follows this track, characteristic track after recurving or southern hemisphere. This we have seen the formation when the ocean surface water is warm, air along above is also warm, evaporation of seawater takes place, wind speed is more, evaporation more will take place. Water vapor rises up to form a cloud. During ascent of water vapor, it cools adiabatically and releases latent heat, which provides energy to form TRS. So this is something you will need to you know, understand carefully and reproduce because of the formation of TRS. During the formation of TRS, what is happening is the ocean surface is warm, about 27 degrees Celsius. Air above is also warm. It causes evaporation of seawater. When the wind speed is more evaporation takes place. During the ascent of water vapor, it cools, releases latent heat. This provides energy to form TRS, latent heat. It is possible that you have 2 or 3 of them nearby and they group together to spin around as one large system. As the air moves upwards and away from the surface, there is a void created, less air left near the surface, low pressure created. Then air from surrounding areas with high pressure fills it up. This new air also becomes warm and moist and also rises. As the warm air continues to rise, the surrounding air spins to take its place. This forms clouds and can go further to form thunderstorms. So we come to a question, why do they move and recur? They are basically huge bodies of air mass with winds blowing spirally inwards all the time. Therefore, they can be considered as rotating air masses. Rotating air mass possesses angular momentum. Angular momentum. When torque is applied to such a body, it starts precessing, like gyrosphere. Torque applied, it moves perpendicular. So Coriolis force actually provides such a torque, causing them to move westwards. Torque applied in form of Coriolis force, angular momentum is there for the rotating mass, and this will start precessing means it will move perpendicularly perpendicular. This torque causes them to move westwards. You know why they move and recurve. We are looking at that answer, why they move and recurve. So it is a question of torque applied in form of Coriolis force which causes them to move westwards. This is basically the thing regarding, you know, large rotating body has a tendency to align to its axis of rotation. We are looking at a fact that you have a large rotating body over Strom or over a smaller body. Then it has a tendency to align with the axis of rotation. This relationship is true in case of storms also. Storms display a tendency to move poleward. High pressure, permanent high pressure at about 30-degree latitude prevents the storm to seek northward course. Therefore, it moves northwesterly. Once it has reached the latitude of westerlies, the northward moving storm gets deflected to the right by Coriolis force, which makes the storm to follow a northeast path. By deflection of Coriolis force, it is made to move along the northeast path. Now, very interestingly, as per the law of momentum, it is always conserved. So, at higher latitude, the radius of Earth is suddenly reduced. Suddenly means if the radius of the Earth is reduced. Since the momentum is conserved, mv, the momentum has to be conserved, it causes the velocity of the storm to increase. Because of the law of momentum, it has to be always conserved. So, since the radius of the Earth is reduced, the momentum to be conserved causes the storm to move faster. I hope you are making a small note or you're following it because this can be asked or has been asked. Why do the storms recurve and why do they move faster after recurving? In short, it is for the conservation of momentum. Now, in these areas, when the water vapor is lesser, in lesser temperature, this will be reduced, availability of water vapor, which is the main source of energy. Therefore, after recurving, because of no availability of water vapor or less availability of water vapor, the main source of energy, which is missing now, causes the storm to dissipate. Recurving and then the storm dissipates. Right? So in short, conservation of angular momentum is the cause why the storm recurs and then loses momentum because of less availability of water vapor. So it will dissipate. Coriolis force is the one which provides a torque. The torque, when applied to a rotating body, produces precession, just like in your gyrosphere. Torque applied produces precession, which makes the body move perpendicular. So this makes it move to northeast fast. You get the point? Apart from the fact that the angular momentum has to be conserved, the very fact that near the pores the radius gets reduced means the velocity increases to conserve the momentum, and therefore when conserving momentum and no availability or less availability of moisture, water vapor, this will dissipate. The storm will then dissipate in higher latitudes. I think you're familiar with the structure of the TRS weather. Atmospheric pressure is one thing, steep atmospheric trace near the eye center, and pressure gradient very high. In the eye, lowest pressure. What about avoiding action? One part which is remaining, avoiding action. Now these are the factors which influence the formation of TRS. Large value of relative humidity in lower and middle troposphere, higher temperature, tropical area, LP surrounded by HP, convection currents, fair amount of Coriolis force, latitude more than 5 degrees north or south, weak prevailing winds during change of season, ensuring large quantity of water vapor present in the air. This is the factors which will give rise to TRS. Air rises continuously, adiabatic cooling takes place, which will provide latent heat. This latent heat is the energy for TRS. Maybe you would like to note down the factors favorable for formation of TRS. Up to you. So points number 1 and 2, large value of RH and high temperature ensure that large quantity of water vapor is present in the air. Point number 1 and 2. Then point number 3 and 4, LP area surrounded by HP area and convection currents. This will ensure that air rises continuously so that adiabatic cooling will take place, resulting in condensation and liberation of latent heat. Latent heat is the energy, provides the energy for TRS. So each point has got a significance that gives a favorable rise to TRS. Continue with the favorable conditions for the formation. Regions during seasons where sea surface temperature is highest means the western parts of tropical oceans during the summer and early autumn. Those are the seasons where the sea surface temperature is highest relatively. An existence of deep, moist, unstable layer of equatorial region. Such layers are found on the regions of highest sea temperature. So existence of a deep, moist, unstable layer. Wind shear least, small variation of wind with height, small wind shear through that region. A previously existing weak cyclonic circulation will be also a favorable thing. This we have seen the warning signs. This can be many ways, including warnings from meteorological services. Swell, yes. Atmospheric pressure falling steadily. Signs के बारे में. Weather, cirrus form in aligned to the direction of storm center. Usually clear visibility might be visible. Increase of wind force as the pressure falls. Frequent lightning, etc. Now, how do you ascertain in which semicircle the vessel lies? It is quite simple. If the wind is veering, the vessel is in right hand semicircle. If it backs, it is in left hand semicircle. This is true both for northern hemisphere and southern hemisphere. If veering, it is in right hand semicircle. If backing, it is in left hand semicircle, irrespective of which hemisphere you are in. It should not happen that wind is veering and backing or changing direction. Once detected, it should be continued, either veering or backing. If the wind is veering at first or backing first and then changing, then it means that the vessel has passed from one semicircle to another due to change of path of storm maybe. So this is the way you can ascertain in which semicircle the vessel lies. You observe the wind if it is veering and you are in RHSC. If it's backing, you are in LHSC, both for northern and southern hemispheres. If you are approaching a stationary TRS, then wind will veer in LHSC and back in RHSC. So the first thing will be to obtain the bearing of the storm center. Then ascertain in which semicircle the vessel lies. That will be the step. First obtain the bearing of the storm center, then ascertain in which semicircle the vessel lies. Avoiding action is always to keep the vessel out of the radius of 200 miles or more. That is the objective. If you are in dangerous semicircle, Then you proceed with all available speed with wind 1 to 4 points on starboard bow in northern hemisphere and keep altering course as the wind veers or backs in SH. Like this. So how do you get the storm center actually? How will you obtain the bearing of the storm center? Quite a simple way. You face the wind. You face the wind, and by Ballard's law says storm center will lie 8 to 12 points on your right in the northern hemisphere and left in the southern hemisphere. To get the bearing of the storm center, you face the wind. Then, following the Ballard's law, storm center will be 8 to 12 points on your right in the northern hemisphere and 8 to 12 points on your left in the southern hemisphere. You see, this is a way to obtain the bearing of the storm center. You face the wind, storm center is 8 to 12 points on your right in NH and left in SH. Storm center can be ascertained. Then comes the question of ascertaining which semicircle you are in, which is also not very difficult. If the wind is veering, the vessel is in RHSC. If it is backing, you are in LHSC. This is good both for NH and SH, northern hemisphere and southern hemisphere. But this is to be done with clear understanding that these bearing you are taking, things should not change. It should not happen that wind is backing and then suddenly bearing. Then there can be error. Irregular gust is a cause. Once detected, either veering or backing, it should continue like that. A veering wind should continue to veer, a backing wind should continue to back. If the wind veers at first, then backs, or it backs first and then veers, it means the vessel has passed from one semicircle to another one. For which I recommend that you go through our textbook of S. Subramaniam Saab for this purpose. He has explained with diagrams very clearly the avoiding action. Apart from the write-ups which we are reading, this is the best method. I was actually referring to this particular section of the book, which you should definitely go through. This one, talking about avoiding action. This is a very good diagram for avoiding action. Northern hemisphere and southern hemisphere. Altering course as the wind veers or backs, depending on which semicircle you are in. Okay, what do you say? Do you have anything to raise for this session? Any question, query, etc.? Nothing you want to raise? Before we actually think about closing it down, can you have a look at this? Maybe if you want to make a note of it. I tried to summarize it. Firstly, what is a dangerous quadrant? Dangerous semicircle, northern hemisphere, southern hemisphere. Then, what is going to be the avoiding action? Dangerous quadrant, proceed with wind 1 to 4 points on starboard bow, alter course as the wind veers. Navigable semicircle, wind 4 points on the starboard quarter, alter course as the wind backs. देख लो अगर if you want you can note it down. Avoiding action. In short, first of all, what is the dangerous quadrant? It is the advanced quadrant in northern hemisphere. What is the dangerous semicircle? It is RHSC in northern hemisphere. So what is the action? First obtain the bearing of storm center, ascertain in which semicircle the vessel is. Then, for avoiding action in dangerous quadrant, proceed with wind 1 to 4 points on starboard bow, alter course as the wind veers. Navigable semicircle, the other one, wind about 4 points on the starboard quarter, and alter course as the wind backs. Here in your chat box, the concise method, it is in the chat box. Avoiding action for TRS. Anything else you want to raise? Do not have anything as you're quiet, you may respond to the chat box. That will do for today's session. Please do make a note of this inside your chat box, the action to avoid TRS. But we are looking action to avoid for TRS in the at sea, of course. Right. Okay, we'll see you again, I think tomorrow, whenever we have the class. For this session, I am done.